Hello, and welcome to the Semiconductor Industry Association's public webinar series, where we address current issues impacting the global semiconductor industry and market. My name is Falanya Nug, and I am the Director for Industry Statistics and Economic Policy at SIA, and I will be your host and moderator for today's webinar. As Congress considers funding incentives for domestic semiconductor manufacturing and research, a new joint study by SIA and the Boston Consulting Group analyzes how such investments would help address vulnerabilities in the supply chain and ensure more of the essential chips our country needs are produced domestically. The report, titled Strengthening the Global Semiconductor Supply Chain in an Uncertain Era, finds that while the current global semiconductor supply chain structured based on geographic specialization has enabled tremendous innovation, productivity, and cost savings over the last 30 years, new supply chain vulnerabilities have emerged that must be addressed by government actions, including funding incentives to boost domestic chip production and research. We are fortunate to be joined today by a group of distinguished panelists for a conversation about the report findings and what they mean for the future of the US semiconductor industry. Mr. Antonio Varas is Senior Partner and Managing Director at the Boston Consulting Group and one of the lead authors of the study. Antonio is a core member of BCG's technology practice based in Silicon Valley with 20 years of experience in semiconductors, smartphones, and connected devices. He has deep expertise in the semiconductor industry, where he serves leading global semiconductor companies across the value chain and all end applications, particularly in issues related to strategy, corporate development, and growth acceleration. Welcome, Antonio. Mr. Raj Varadarajan is also Senior Partner and Managing Director at the Boston Consulting Group. Raj leads BCG's global advantage efforts in North America, which includes geopolitics and trade and public-private sector collaborations, and is also a senior leader in BCG's TMT, or Technology, Media, and Telecom practice. He has over 30 years of experience working with large clients on multi-year transformational efforts across a number of sectors, including chemicals, EPC, airlines, telecom, tech, OEMs, and semiconductors, of course. Welcome, Raj. Ms. Susie Armstrong is Senior Vice President, Engineering at Qualcomm Incorporated. Susie started at Qualcomm working on Globalstar and then early CDMA base station projects. She was a pioneer in bringing internet protocols to the cellular industry, resulting in the first web surfing on a cellular phone in 1997 and Qualcomm's commercialization of packet data in 1998. Since then, she has held various leadership positions, first responsible for the development and commercialization of all the software that drives Qualcomm's chipsets, and then as the head of worldwide customer engineering. In addition to her work on Qualcomm's inventions and new technologies, she has worked extensively with base station makers, carriers, phone and device makers in the US, Asia, and Europe to bring those technologies to market. In 2015, Susie joined Qualcomm's Government Affairs Group, where she brings an engineering and product background to government affairs work in worldwide public policy, including intellectual property protection, cybersecurity, STEM, and STEM diversity. Welcome, Susie. Ms. Jackie Sturm is Corporate Vice President, Global Supply Chain Operations at Intel Corporation. Jackie leads operations for Intel's multi-billion-dollar global supply chain, which has been cited as number 8 or better for 9 consecutive years in Gartner's Supply Chain Top 25. Her international team supports construction and facilities sourcing, indirect procurement, business continuity, supply chain systems and analytics, and supply chain environment and social governance program, which includes Intel's first mover conflict minerals initiative. Jackie is a committed advocate for the criticality of value-added manufacturing, engineering, and trade as the economic foundations of thriving societies. Within global supply chain, Jackie sponsors targeted advancement programs to address challenges faced by women and unrepresented minorities in technology. Prior to joining supply chain, Jackie held various finance positions at Intel, including CFO for technology and manufacturing, as well as at Hewlett-Packard, Ridge Computer, and Apple. Welcome to you, Jackie. Finally, Dr. Chad Bown is Reginald Jones Senior Fellow at the Peterson Institute for International Economics. His research examines international trade laws and institutions, trade negotiations, and trade disputes. He co-hosts Trade Talks, a weekly podcast on the economics of international trade policy. Bown previously served as senior economist for international trade and investment in the White House on the Council of Economic Advisors, and most recently as the lead economist at the World Bank. Before joining the Peterson Institute, Bown was a tenured professor of economics at Brandeis University for 12 years. Welcome to you, Chad. Antonio and Raj, as the lead BCG authors of the report, let's start with you to help us understand the report and its main findings.
So, good afternoon, everybody, and thank you very much for having me here. I thought I'd start off, if you could go to slide 1, Falan, by just setting a little bit of context on this. The semiconductor industry, putting it in context in other industries, it's an industry that ranks simultaneously high in both R&D and capital intensity. So if you look at industries like software, media, tech hardware, et cetera, semiconductor industry is about 50 to 200% higher on R&D intensity. Pharma is the closest to the semiconductor industry in R&D intensity, and even that, I think, in 2019, the semiconductor industry was higher than pharma. If you look at the high capex sectors like trucking and power gen and utilities, again, the semiconductor industry you'll see on the left in green is higher than all of them. Of course, within the design part of the value chain has more of the R&D, relatively speaking, and on the manufacturing side is more of the capex. But if you look at the industry as a whole, it's basically a high capex and a high R&D sector. And I think that just sets some good context for how the challenges of this industry are relatively unique. So if you go to the next page, Kalam, on the left side, it isn't a surprise to anyone on this call that this supply chain is very complex and is very global. But I don't think that this fact is appreciated much by the world at large. So on the left, there's a very simple sketch of the supply chain. You see a little bit of the R&D at the top, and then you have EDA and core IP feeding into the design side, and you have equipment and materials feeding into the manufacturing side. Just a very simple sketch of the value chain. And on the right side, you see market shares by country, if you will, in each segment of the value chain. And you can see that there is geographic concentration, the thing that Falan alluded to at the beginning. So on EDA, on core IP, and on logic, you see the US in leadership with greater than a 50% position, if you will. And then on wafer and on fab and on memory and materials, I think you see East Asia as having a leading share. So different parts of the globe have got different kinds of shares in each of this. And all of you on this call know how many different places the chip traverses before it ultimately makes its way into the device that's in our hands, if you will. But all of this stuff is very complex. While it's very complex, it isn't without value. So if you look at what we tried to compute was, what are the cost savings of this incredibly complex global supply chain, if you will, compared to a fully localized, self-sufficient supply chain, if every country made it within their geographic boundaries. And what we calculate is roughly about $1 trillion to $1.2 trillion in avoided upfront investment by having the investments happen in concentrated areas and then having the materials flow around, and about 45 to 125 billion in annual cost efficiencies. And the net result of all of this is that the end semiconductor prices are about 35 to 65% lower. So this enables a reduction in the semiconductor prices, which of course means that there is more of an adoption, there's more of an uptake, there's more volume given the lower prices, which then allows us to make more revenues and reinvest in R&D and innovate further. So it's a virtuous cycle that this global supply chain has enabled. If you go to the next page, Falan, we've just laid out essentially, while you have all of this complexity and you have all of this value, you also have some vulnerabilities. And I think the recent events, be it the power issues in Texas or the COVID-related issues overall, or the auto shortages that we're currently seeing, have just highlighted the fact that having a supply chain that is constructed as it is makes it not very resilient. And so the industries that depend on semiconductors have faced significant issues. So we've identified 5 key vulnerabilities. There's a high geographic concentration of some activities, which is what we just talked about with the data up front. There's obviously also the geopolitical frictions, which all of you are very well aware of, and we've written about the US-China part of the geopolitical frictions in our early reports with the SIA. There is also issues related to nationalistic self-sufficient related policies and what that could entail in the future. There is talent constraints, and there is stagnation in funding of basic research, because most of the research in this particular industry, most of the research is really funded by the industry. There isn't as much as a percent of overall, there isn't as much in basic research funding by governments or other institutions. So our report focused on the first piece, which is the geographic concentration of some activities and what are the issues. For example, you got wafer fabrication or assembly packaging and testing, some specialty materials, and of course, the fab capacity imbalance, if you will. So we've looked at what are the issues created by some of these. Antonio, do you want to pick up the next points from here?
Yeah, thank you, Raj. So we did an exercise of mapping the geographic concentration of certain activities across the supply chain. It was not entirely exhaustive exercise. There's hundreds of materials that go into the production of semiconductors, but it's quite comprehensive. So the summary that this slide presents shows that we found at least 50 points in the semiconductor supply chain where at least 2/3 of the global share is concentrated in suppliers in one region. Obviously, not all these points create the same type of vulnerability. Clearly, interruptions in manufacturing or supply of materials have an immediate effect on the supply chain because they disrupt actually the physical delivery of the components. In other cases, on the design or equipment tools, the risk is much more the possibility of restrictions to access to the technology or IP, but don't carry an immediate risk of interruption in the supply of components. Also, from a US perspective, it's worth noting that in many of these points of concentration are actually either the US itself or in countries that are allies. And the one point that is particularly sensitive is manufacturing, wafer fabrication that you see there in the middle. And that is because the manufacturing capacity today is very concentrated in East Asia. That includes China, but Japan, Korea, and Taiwan. So if we go to the next slide, and we take a deep dive at decomposing the location of that manufacturing capacity, we see that this region, East Asia, including China, concentrates 75% of the wafer fabrication capacity today. And that is true pretty much across the board, across all types of semiconductors. It's true in memory, as you see there, but it's particularly concerning in the case of the leading node. Those are the fabs that are able to manufacture at below 10 nanometers. That is a small portion today of the total world capacity, just 2%, but obviously is the highest growth, and is the capacity that manufactures the most advanced semiconductors. And 92% of that capacity today is in Taiwan, 8% in South Korea. So that's the extreme, but you see that that concentration in East Asia is pretty much across the board. In the case of the US just accounts for 12% of the global capacity, so that's clearly below the level of US consumption that we estimate at 25% of the global demand. So the question becomes what to do about it. This is in that concentration of capacity, as Raj was saying, is not just a risk for the US, it's a risk for the resilience of the global supply chain. And we have to remind ourselves that this area of the world, East Asia, is an area of high seismic activity, and also is an area that is very exposed to geopolitical frictions. So in our report, we look at potential policy and industry approaches to improve the resilience of the supply chain by addressing this challenge. The next slide, please, shows an example. So rather than pursuing blanket self-sufficiency, rather than trying to say, well, every country should build its own manufacturing capacity to cover its own needs, semiconductor needs, and that, as I said, well, the cost of that is staggering, even questionable feasibility. We think that a more practical and feasible approach has to be more targeted. So what we show here is an example for the US, where we look at, rather than trying to build a capacity to cover the entire US consumption, we focus, well, of that consumption, about a third is in advanced logic. That's the area where I just mentioned, that's that high concentration in Taiwan. And of that advanced logic, that is 34% of US consumption, really of that, there's 9% that is coming from applications that we call critical applications. That's essentially defense or space, infrastructure like telecommunication networks, energy, or also government data centers. So rather than trying to build fabs to cover entire 100 billion US consumption, that, as you see there, that will require building 60, 65 new fabs and a cost that exceeds $1 trillion. And a more targeted approach would be to build this minimum viable capacity to cover that just 9% on the right of critical, that comes from critical infrastructure. And for that, you need about we estimate 2-3 new advanced fabs with a total cost of about 60 billion. That, as we discussed in our report last September, would require government incentives to be able to attract these investments. But it's a much more focused, targeted approach that is also market-driven and does not introduce distortions in the market or the risk of creating overcapacity. So I think this is a quick summary of the report. Again, we'll pause here and then happy to address also questions later on.
Appreciate that. Antonio and Raj, thank you very much. And I certainly would recommend the report to anyone. It's on our website. It's on the BCG website. It's quite in depth. There's a lot more that is in the report that Raj and Antonio didn't cover. So by all means, certainly recommend it to folks. Susie Armstrong, I would like to turn to you next to get your perspective on both the value and the vulnerabilities in the semiconductor global supply chain, especially from Qualcomm's point of view, which operates as a fabless semiconductor producer and that focuses on chip design. Can you give us Qualcomm's point of view?
Sure. Thank you very much, and thank you very much for the invitation. I just have one background slide here, just in case people have never heard of Qualcomm. When we would bring STEM kids to our Think a Bit lab, we used to brand the stadium in San Diego, and all the kids thought they were going to the stadium. So Qualcomm is probably the leading fabless company, certainly in the nation, if not the world, in terms of wireless and mobile technology. We've, over the course of our existence, and I've spent 27 years of my career at Qualcomm, mostly in the chipset division. And so I know this to be very true. We've spent probably over $67 billion in cumulative R&D, 140K patents or pending applications. And so Qualcomm is really, in it for the long game. We do the inventions, the 5 to 10 years of research in mobile technologies and efficient use of spectrum. And we are a very strong participant in standardizing those technologies. And then we bring those technologies to life in the form of chipsets that go into, not only phones, but IoT devices, in some cases, cellular infrastructure, and all of those wonderful use cases you can think of with 5G going forward. So there's 3 points I want to make in these opening comments, and none of them are going to be a surprise to anybody out there. But what's critical for us, and I believe for U.S. leadership in this conversation around manufacturing, and that is R&D is critical. If you don't have R&D, you have nothing to manufacture. And so this is an area that the U.S. has traditionally led in, both with fabless companies like Qualcomm and companies that do integrated operations. So we very much welcome and participate in the conversations around bringing manufacturing to U.S. soil, especially some of the concerns about, I think especially well-founded are some of the concerns about access. But we also need to make sure that we recognize and support that R&D that drives that manufacturing and takes advantage of that manufacturing, because there's very competent competition out there in the global industry for that leadership position in R&D, and I think it's very important that policies recognize that. The second is that mature node chips are essential. There's a lot of discussion about, good discussion about leading edge semiconductors. We certainly, make our Snapdragons in the most leading edge technology nodes. But if you look at, for example, at a typical smartphone, and we've done teardowns, there's probably 169, I think it's the number, 169 semiconductors or dies in that phone, and 95% of them are not leading edge. 95% of them are, I think, 28 nanometer and above. And anyway, and I think this is a dynamic we're also seeing in the automotive industry right now. Any one of those chips that are missing can gate the entire device, the shipping of the entire device. And so there, again, I think the conversation has to include how we either build or maintain or expand access to mature node components. And it's not an easy conversation, because these are components, many of them that the manufacturer makes pennies on each device, and it's old technology, so it's difficult to obtain. And I guess the last, which sounds kind of silly after the BCG presentation, is the supply chain is really complex. And in fact, chain is not really a good term for it. It's more like the supply spaghetti or something much more complex, because it's very, very intertwined, and it's not, and addressing these access issues is not a cheap, easy solution, and it's probably not even an easy, expensive solution. So I think we have to look to allies. I think we have to look at strategic, maintaining strategic access, for some chips in different parts of the world where we might not, want to maintain access, and we have to look at, second and third sources. But just in summary, we're really happy to, and we're very involved in the conversations around the semiconductor manufacturing. It's very nice to actually see and hear semiconductors be sort of day-to-day conversation in policy circles. And our point is that, and my point is that, the best time to have started on this manufacturing and access project probably would have been 5 years ago, but the second best time is today. So I really welcome the chance to hear the questions and participate in this webinar. Thank you.
Appreciate it. Thank you, Susie. Yes, there's no time like the present. So that's what's going on in DC, certainly. Jackie Sturm of Intel, I'd like to next turn to you and I basically essentially ask you the same question that I posed to Susie, but given Intel's perspective and on the values and the vulnerabilities of the semiconductor global supply chain. And I think, as an IDM, that does the design, the front-end fabrication, the back-end assembly, test, and packaging, help to get an understanding from Intel's point of view of where those risks are, what the value is in taking advantage of global supply chain in terms of your, as Susie said, super complex global supply chain for the industry, and I'm sure for Intel.
That sounds great. I'd love to talk about that, Fallon. And if you can show my slides here.
Mm-hmm.
Okay.
Let me go. There you go.
Yeah, I think this is a really valuable discussion. And I'm so glad to be here on this panel. I loved hearing your comments, Susie, and I think it's crucial for us to think about the supply chains. As you said, 5 years ago would have been good, but today is perfect. I think most of you know about Intel Inside, but it's an integral part of everyday life for most people. It's in our PCs, in our data centers, or the global network infrastructure. And as a company, we have a purpose, which is to create world-changing technology that enriches the lives of every person on Earth. And that's not an empty claim. We're not just talking about our technology. We also strive to have an equal, if not greater, positive impact from how we operate our factories, as well as through our global supply chain. We've been in business over 52 years, and over that time, we have been and we continue to be very focused on great corporate citizenship. And that extends to a lot of things that we value. It might be supplier diversity, human rights, carbon footprint, among many other areas. And as we heard from other speakers, the semiconductor industry is extremely integrated. It's a global web, or spaghetti, as Susie would say, that allows us all to create great products. On Intel's behalf, we're able to produce over 10 billion transistors per second to support the needs of our customers as well as their end customers. If I can go to the next page, I'd like to talk a little bit about our global footprint. As you mentioned, we are an integrated device manufacturer, also known as an IDM, and that entails designing and producing state-of-the-art logic integrated circuits or microprocessors throughout our global manufacturing network. But I want to point out that our operations in the United States are at the heart of our ability to advance the technology. As Susie pointed out, R&D is a crucial factor in the progress of this industry. And for us, of that 110,000 employees who work for Intel, over half of those are in the United States, and they're working in high-tech jobs and also creating an ancillary industry to support our businesses, which had over $100 billion of impact to US GDP just in 2019. And our chip manufacturing, our process technology, and advanced packaging know-how are all developed within the United States. That's the center of our research and development. Also, because of that focus, and despite the cost challenges that we face in growing domestic operations, we continue to increase most of that support in the United States well into the future. You might have heard 2 weeks ago, our CEO, Pat Gelsinger, reiterated our commitment to US manufacturing when he announced an upcoming investment of an additional $20 billion to build 2 new fabs in Arizona. And that's really just the start of our plans, because US and global capabilities are critical for us to meet the needs of our customers. In order to support all of our operations, we have to rely on a globally integrated, but also globally distributed network of over 16,000 suppliers. And each of these have deep specializations in equipment or high purity chemicals, manufacturing materials. And they've accumulated these skills and specialties over the years through their own experience, as well as the investments that they make in R&D, some of which happens in the US, but some of which is done around the world. What we've found is by harnessing the collective capabilities across the ecosystem, we've been able to deliver the chips that power the digital infrastructure of the world without doing it all on our own. However, due to the global nature of modern supply chains, semiconductors in particular face numerous risks that challenge our resilience as supply chains. And I would say this happens on a daily, if not more frequent basis. It's not just limited to major events like COVID. So if I can go to the next page, please. In the 12 months alone that comprised 2020, I'm sure the issues on this page seem all too familiar. And I could spend hours talking about all of them, particularly the successive waves that have affected us from the pandemic standpoint. But our playbooks at Intel are prepared for these kinds of things because the pictures on the page are real situations that occur to us on an ongoing basis and allow us to exercise and generate quite a bit of muscle memory in responding to critical disasters. One great example of how we've prepared ourselves to maintain resilience is back in 2003. When SARS was a concern, we established a pandemic leadership team that was ready when COVID hit us. And the first thing that we always care about is the safety of our workforce and the extended supply chain workforce. But once we address safety, we also have a deep and disciplined set of practices that allow us to monitor and ensure that all of the elements of plan, source, make, and deliver are in place. And that was crucial for us with COVID because, as I think most of us know, demand shot through the roof to support remote work and online education at an unprecedented level. Fortunately, we had activated our own command center in mid-January of 2020, before I think most of us knew what was going on. And through that operating model, we were able to continue to provide for our customers. We did a lot of things, but one example that I thought was particularly interesting in terms of continuing to foster and leverage technology as a way in which supply chains can help support our businesses is, AR, VR. Fairly nascent technologies, but because during COVID, most of our suppliers were not able to travel to maintain our highly sophisticated equipment, we used AR, VR, and GoPro solutions so that we could connect our engineers thousands of miles apart to work on equipment, some of which is valued at over $100 million per item. And not only did we do this during the disaster, but as things have loosened up, we're actively engaging to do more. So sensing, preparing, and mitigating risks through innovation as well as standard playbooks are key to supply chain management. And those supply chains are how we're going to continue to enable business results. If I can go to the next page, I'd just say that world-changing technologies in 2030 are going to have their roots in today's research and development. Our supply chain stays very closely connected to all of our internal and external stakeholders so that we can enable those future technologies and products to reach the market. This means that we need to have very close partnerships with cultivating nascent technologies, as well as understanding the global regulatory landscape that can impact those innovations. Means we have to be ready to forecast what demand will be years in the future if we're going to invest to support that. And we do that through sensing, looking at customer preferences as they shift, and then enabling supply through expanding our existing sites or working with communities and governments to build new sites. By proactively planning and preparing for what the future might look like, our supply chain continues to be a driving force to enable not just Intel's future, but the benefits of all of our stakeholders. Now, the last thing I'll say is, as Intel plans for major investments, it's vital that the business environment remains, if not stable, at least predictable, and hopefully favorable for industry over the course of these multi-year programs, not just for Intel, but for all semiconductor manufacturers in the future. So this next page, I just want to say, We partner with governments, we partner with academia, regulators, fellow travelers like the SIA, so that we can help drive policies that are going to support corporations like ours in the near term and the long term. And that includes investments to create a level playing field, building better infrastructure, and building a stronger STEM talent pool for our high-tech companies, along with fair tax treatment. Pat Gelsinger is our 8th CEO, and he, like all prior CEOs, is passionate about our future and is deeply committed to the US as a center for innovation and for manufacturing for years to come. If we can get the right policies and collaboration together, we intend to be not just a technology leader, but also a continuing engine for growth in the US and in global economies. Thank you.
Thanks, Jackie. I really love the point you made about how that risks are often on a daily basis, and I'm sure in your position at Intel, you probably are very aware of all the various types that are part of operating such a global supply chain. So appreciate that. Finally, I want to turn to you, Chad Brown, to get your thoughts on the report findings overall. And I'd love it in particular if you would be able to share your thoughts on the report's policy recommendations, in particular to address domestic semiconductor manufacturing supply chain vulnerabilities.
Absolutely. So first, let me say thanks for the opportunity to be with you. And just so everybody on the webinar is clear, I'm the least expert in this industry. And so and sort of learning as much by just being part of it. And also I want to congratulate the authors of the SIA and BCG report. This is the latest in a number that they've put out over the last year and a half or so that have been incredibly valuable. They're very clear. There's a lot of data. They're taking great care to try to explain the nature of this industry, which is super complicated to the broader public. And as a consumer of this, I just want to say thanks and congratulate you on another study. That being said, this report is very diplomatic in terms of its discussion of policy. And as someone whose job it is to analyze policy, I'm an economist, I'm a trade economist and follow policy. I'm going to be a little bit less diplomatic and to try to get to the heart of some of these issues. This report is about uncertainty. And so I think a key element of uncertainty, as we've seen during the pandemic, you can imagine uncertainty coming up in different forms, affecting the supply chain, one of which might be something like, imagine the outbreak of COVID-19 had not been in Wuhan a year ago, but had been in Taiwan. What would that have meant for the industry, right? It could have been devastating for a period of time if, imagine the island had gone into lockdown, something like that. And that's certainly something that needs to be considered. But what I want to focus on here today, and which is largely, I think, driven the nature of a lot of this work over the last 2 years, has been the policy uncertainty that's been created by governments and the risks that are being imposed there. And so what I thought I would do is to kind of make 2 points and then maybe to ask 2 questions to the authors of the report. So one of the points that I want to make is essentially, the way I interpret the report is, it's essentially saying, look, the way US policy especially has evolved over the last couple of years, we're seeing all of these export controls, whether it was on Huawei and then on foreign suppliers through the Foreign Direct Product Rule, potentially on SMIC. The concern, or that this is not the end of the story, right? So this leads to other countries, China in particular, to perhaps doubling down in terms of their indigenous promotion of their own domestic industry, more subsidies there. And then you have other concerns, which are the huge consumer base in China. So you think about all of the other smartphone makers, for example, and I don't think it was in this report, but I seem to remember a number of in one of the earlier reports that you all did that was something like, a quarter of all US semiconductor revenues come from Chinese device makers. Right? And the concern is that other device makers look at these export controls getting put on by the United States government and saying, well, the United States does not look like a reliable supplier. Let me look potentially elsewhere. And obviously the concern is for an industry like this one, that's a threat to revenue. And with so much revenue being at risk, revenue is what drives R&D, keeps the United States industry at the forefront of this industry globally. And if you're going to take that away, it needs to be offset somehow, right? And so this is why now all of a sudden we have to go to Congress and thinking about potentially subsidies to R&D that are foundational, pre-competitive, but haven't been there and haven't been these sorts of requests in the past, right? So I think that's a clear implication coming out of this report. The second is, though, a bit more broadly, in talking about subsidies more generally, this is a big shift in the United States policy position, right? For any industry, right? We have historically been the leader trying to rein in subsidies around the world. I liked very much how the report highlighted the OECD study of about a year and a half or so ago on the global industry that noticed that everybody else was supplying. And this very much sort of says, you know, this is or recognizes a US change in policy stance, right? We're no longer going to be going after and trying to rein in other countries' subsidies, maybe recognizing that US administrations are not pursuing that anymore. And thus, you know, if you can't beat them or stop them, I guess we're gonna have to join them. But I think there are implications of that, right? It's not clear to me that that's the end of the story, that other countries won't just subsidize more, which will lead to, you know, perhaps overcapacity sorts of problems. And we know this industry has a history, if we think back to the 1980s, 1990s, early 2000s, of lots of trade remedy cases, countervailing duties and stuff. And you can imagine the world being very different today than what it was 20, 30 years ago, because the United States is a much smaller importer. When the rest of the world is importing chips, our companies are now much more exposed, I think, to those sorts of trade policy actions in the ways that they weren't historically. So I think that's another concern that I would bring up. Two small questions, and then I'll end mine. Is in the report, when we're talking about and how you've modeled the potential subsidies necessary to reestablish or increase manufacturing in the United States. The first concern is with all of these export controls over the last year or so, and then the administration's invoking the Defense Production Act, not necessarily in semiconductors, but elsewhere, there's a lot more government involvement in industry than has been the case historically. So does that then actually create a premium? That if you want manufacturers to do stuff in the United States, you have to pay them more than you did 2 years ago or 5 years ago, because now you may be constraining what they can do in the future. If you manufacture those chips in the United States, you could be subject to American export controls, not be able to sell them abroad. Or, you know, if something comes up like today with the auto industry, the government may come to you and say, hey, we want you to stop making all those chips for, you know, Zoom and kids schooling at home. You need to make more for the auto sector, right? Well, that sort of leads to me to sounds like a premium that you might actually be paying to manufacturers to actually get them to set up their plants here. And then lastly, when you model this, so you know, are you modeling that? And then the last question is, with your projections of what it would cost, so Intel's an IDM, but you know, some of the manufacturing facilities, TSMC, are you also taking into consideration the sort of extra costs of doing the packaging and testing and stuff, having to do that here in the United States? Because the export control laws are geographic in scope, right? And I would imagine Congress is not going to give the industry the money unless it can have some guarantees that it's going to be able to tap into that output along the way, if they want to move it for national security reasons or whatever. And so the idea that you would manufacture it here, but then potentially ship it to Singapore for packaging would remove its grasp, right? The geographic nature of these export controls. And so do you take that into account, the sort of extra costs of actually having to package this stuff here as well? Anyway, lots to think about, a great report, lots of questions, and thanks for including me.
Thanks, Jed. Yes, definitely a lot to think about. You put a lot on the table for all our panelists to consider. I'd like to turn now in the time that we have remaining to Q&A. So I remind folks who are attending to go ahead and, if you'd like to submit a question on the Q&A button, and we'll try to get to it and address your question. I thought I'd just kick it off initially as folks send in their questions, and loop back to you, Susie, and talk a little bit about, again, the R&D. I think you mentioned it before, the criticality of R&D. And I wanted to just delve a little bit deeper into what you were talking about there. How is R&D critical to chip design leadership, especially domestically? And how can that be done to further strengthen a robust R&D ecosystem? The R&D is complicated both in terms of the pre-competitive basic research that needs to be done often outside of industry, sort of in government or academia, and how that relates to and helps what the domestic industry is doing on the R&D side.
So thank you very much. And this is, of course, a topic near and dear to our heart. And Chad touched on it, some aspects of it as well. So the R&D, and you can see from some of the charts in the BCG reports, the US has led in R&D, both in companies like Intel and Qualcomm, who are designing these chips, and also tools manufacturers doing their R&D and their IP in the US. We have traditionally led in the R&D area, and you've got to, of course, as I said before, you've got to have a design in order to have something that you want to actually have manufactured. So we cannot lose sight of that, and the R&D aspect is actually what's put us into a relatively good position vis-a-vis competitors to date. And so losing that R&D edge means not just loss to companies who do that R&D and loss of jobs and such. That means loss of fundamental technology leadership in the US. Case in point is we used to have, many years ago, we used to have Bell Labs, and we used to have Lucent, and we used to have Canada's Nortel making, cellular infrastructure, and we used to have Motorola and TI being involved in all kinds of R&D. And those companies, you just see them, some of them have been, bought or consolidated, and it's an alarming technology sort of R&D slide that needs to be supported and stopped. And so one of the ways to support it, of course, some of the discussion around and the proposals in some of the bills for funding basic university research is really good. But I think, as Chad mentioned, US companies, we, in some ways, China makes the world's electronics devices, and a large portion of the world's electronics devices. And if you look at it, its access to those global markets is what funds US R&D. And so keeping access to those global markets, keeping access to global supply, I think is critical to keeping that R&D funding. And the other thing Chad mentioned is, you might want to look at subsidies for R&D if you're going to replace, if you're going to try to bring manufacturing and R&D onshore. And well, I think that's something to look at. I think, people considering that have to look at the scale of what companies do. We've been, asked before, well, can you replace some of your global markets with, US or military contracts and such? But if you look at the scale of what we ship and what a company like Intel ships or a company like Micron ships in terms of parts, it's really not replaceable. And that's why the whole decoupling from China conversations get us very, very worried. And my other point about R&D is it's really in the R&D area where when you're setting the design of a chip, for example, that's where the basic functionality goes in, and that's where the basic security goes in as well. Not that there's not opportunity for IP theft and potentially backdoors elsewhere in the process, but security really starts with that R&D. And so I think we can't pay enough attention to the R&D aspects as we are talking about this very critical aspect of manufacturing.
I appreciate that, Susie. Yeah, I definitely think, and I want to underscore certainly the point you made about how sales abroad or access to all markets definitely helps to to keep and helps companies reinvest in R&D at a high level. That certainly was sort of the main finding from our initial BCG report. And that helps with the long-term, sort of keeping the long-term edge. If you have, good market share and you're able to reinvest at high levels back in R&D, that again helps you prepare for not just the near term, but the medium and the long term in terms of staying at the leading edge and competitive. Jackie, I wanted to ask you a question on the manufacturing side. We talked about R&D, which is critical, and but manufacturing, what Intel does, these major investments of fabs, as we learned in our last report that we did with BCG last fall, are major investments, billions of dollars. And I guess where to build a fab is just a major decision for any IDM such as Intel or Foundry. I'd be curious to understand a bit more from your perspective, from Intel's perspective, of what are the broad criteria that you folks consider when you're thinking about where to make your put down your next big manufacturing investment. And we all know that the market is growing. There's long-term growth drivers. There's going to be a need for more fab capacity, and that's not in dispute, right? There's and I guess the question is, for a company like Intel, it's not do we need to build more fabs? It's where are we going to do it?
Yeah, that's a great question. And as you think about putting a multi-billion-dollar investment in the ground based on what you think the future is going to look like, there are lots of considerations that generate some deep thought. And I'll give you a short list. It's not comprehensive, but the major things that we think about are, first, what's the workforce capability? What's the STEM education level? Do the people on these in these countries or in these regions have enough technical background to be able to work with our complex equipment, to be able to conduct the process engineering that's required? What kind of language skills do people have? And also, is there a meaningful pool of a workforce that we can rely on? And I think that also dovetails a little bit to the R&D topic that Susie was talking about, where educational policy that fosters STEM is something that is supportive. We clearly look at incentives, as well as is there a predictable or favorable, but predictable is most important, tax and trade environment that supports manufacturing and cross-border movement of material or products. What's the regulatory environment like? We're also looking for low corruption. We want a regulatory environment that's robust, but not heavily restrictive. We want to have access to, the infrastructure, the power and water that are required to operate these sophisticated facilities, and also political stability, strong industrial policy, and the potential that, if it turns out to be very good for us, that we can also expand in the future to build more facilities that might leverage some of that workforce and infrastructure that we've invested in. So those are some of the key points.
Perfect. Yeah, I know we haven't talked about it in the panelists' opening remarks, but I definitely want to underscore workforce. I think just thinking about the idea of having more domestic capabilities will certainly necessitate a need probably to, again, sort of get our STEM policies correct for improving domestic education in science and math, and also, of course, high skilled immigration. So certainly very important to think about as we're thinking about all these new sort of changes and policies. We have a few more minutes left, and I see we have a bunch of questions that have come in, so I appreciate that to the audience. I thought I'd just look in, if any of the panelists have ones that they want to look to respond to, please let me know. But I thought there's one here about the semiconductor industry has been prone to boom and bust for the lifetime of the industry, essentially. What makes this cycle different? It seems that the cycles could be even more severe given the huge capex required for new fabs. I don't know. I think Antonio and Raj, I think we sort of addressed this in certainly this or definitely I think in the domestic manufacturing report, knowing that, you know, yes, there is boom and bust in the cycle, but I know the analysis you folks did looking long term, you know, over the next 10 years. There seems to clearly be growth in the market. And it's, again, as I mentioned to Jackie, it's not a question of does new fab capacity need to be added, but you know, where and is the question for companies, IDMs and foundries, and what are the criteria, right? So can you maybe expand a bit on that?
Yeah, maybe I'll go first, and then Raj can add. Yeah, I think, look, the study we did last year, we took a long-term perspective. So we look at what is the capacity in the industry needs to keep up with the expected growth in demand. That, look, is 5% CAGR over the next decade. So, and is very consistent with the historical trend. If you look at the current report, especially after the last year and the current shortage, actually, most analysts are thinking that probably we're going to be 8 to 10 in the next 30% growth in the next 2 to 3 years. So definitely the industry needs to add capacity, and 5% CAGR over a decade is almost you're adding 50% more capacity than you have today. So there's no doubt that more capacity is needed. I think the question is, where will that capacity that the world needs be built? And this is where our position is, well, the world, not just the US, the world, the industry, and the industry downstream needs a more diversified manufacturing footprint. So even aside for national security considerations, having 75% of the capacity concentrated in an area that is exposed to those disruptions is not a good thing from a supply chain resilience perspective. So this is not about being or just protecting the US. This is actually, we believe, is good for the entire industry.
Raj, you want to add anything to that?
And yeah, the thing I would say is that there's a point about resilience, but I think also the whoever asked the question specifically asked about boom bust cycles, which you're talking about over and under capacity. But over and under capacity is relative to demand. So if you think that there's economic cycles which create demand shocks, which then translate right back into the semiconductor fabs, which then have a very high fixed cost, and therefore if your utilization goes down, you suffer financially substantially. Economic cycles, I think, will always exist. But I think there are two other factors which I think are different. One is that when you have a large number of players, and we've seen this boom bust cycles in industry after industry, high asset intensive industries, that during, sometimes you add a tremendous amount of excess capacity, and then, the industry is over capacity. But that happens a lot more when you've got a very high fragmentation in the industry. And I think over the years that the industry itself has become a little bit more consolidated and more capex discipline, if you will. And then the second piece is on the demand side. Semiconductors, the incremental quantum of capacity, the second point of capacity, that incremental quantum of capacity, if the base is low, then each thing that you add adds substantially to the capacity. And now we've got a pretty substantial capacity, and the incremental quantum as a fraction of the total base capacity is not as high. And the third point I'll make on the demand side is that in addition to capacity discipline, the industry has gotten a more utilization discipline. So when something falls off, demand for something falls off, they switch to other things. So the auto thing is a big example. Auto demand fell off during COVID times. The industry switched, a whole bunch of the chips went into computers, but the demand shot up. The capacity was repurposed. And I think the capacity utilization has been fabulous. So I think that the demand and supply and industry structure are consistently getting different over time compared to the years past.
Got you. Appreciate that. I know we have just a minute left. Any last comments or from the panelists? If not, I'll think we should probably go ahead and end it there. I know we have a ton of questions, and again, I do appreciate the audience for sending all your questions. I think this is obviously a very timely and interesting and popular topic. Again, I highly recommend folks read the report. Go to our website, www.semiconductors.org. Check out the report. If you have any follow-up questions for either the authors, Raj, Antonio, or SIA, by all means, please feel free to reach back out to us. But again, thank you to Antonio, Raj of BCG, Susie Armstrong of Qualcomm, Jackie Sturm of Intel, and of course, Chad Bown of the Peterson Institute for participating in today's webinar. And I hope to talk with you guys soon.
Thank you very much.
Thank you.
Bye-bye.
Take care.
Bye-bye.